don't want to teach the theory as such, because yeah, we are learning theory.
So the 12th one, I couldn't solve that.
12th one, okay, let us try that. This problem set has good questions, if you see, right? It's chosen by, so this is a problem number 12, and it's apparently original to the author. I think this is the real name of the author, if I remember correctly. So yeah, so this is problem 12, and this is due to, let's give the credits, David. I don't know how to pronounce that one. Altisio. So triangle. So there's a picture is here. Okay. So let us draw it here, because we may have to do some surgery picture. So we have this, and then we have a right triangle in it. This. So AE is 4 and EF is, so we have the standard 3, 4, 5 triangle. Yeah, you have to figure out the square. So we're going to go back and find the square. AB, area of AB. Yeah, just now again, see, this question cannot be very difficult, because if you just put, let's try X, Y, or maybe doesn't matter, but X plus Y, right? X. Then if you just put right equations, you should get the solution. But is it that easy? But it seems so, right? So this one is 16. Oh, wait, sorry. That's not X. FB is not X. Okay, let's think. It can be done, is because if you put this to be Z, and then this becomes X plus Y minus Z, then you have 3 equations, 3 solutions, three equations, 3 way unknowns. But that would be very tedious. And then we can just solve this, right? This will give the answer, but it's going to be very tedious. So let's try to think of alternatives. you see that this triangle is unique. The unique triangle you can make like this.
Sir, if we see that like ADA is 90 degrees, so if we take angle DAE to be uh, maybe W,
Mhm.
then angle DEA will be 90 minus W, right?
Mhm.
And because like DEC are collinear, so angle CEF will be W again because
Yes, that's
angle
right.
AE.
Yes, that's right. So those are similar triangles. Yeah. So those are similar triangles. So that takes care of the Z. So you don't really need to write an equation for Z. Uh, yeah, I mean, you can express Z in terms of these things. So my point is you can forget one equation and you can write what is Z. Is that this nice symmetric thing? But there are many things we can do, but to find the right way. Like this AEFB is cyclic, so you can apply Ptolemy's theorem. But that I don't know, you'll get some more variables and yeah, AEFB is cyclic because the opposite of 1990. But I have to use it. Yeah, this is not done because these two equations, I don't think they are that easy to solve. There are only two variables, but when you expand it, can we do that? Can we just expand it? So this x plus y whole square is 16 minus x square. right? And then, so this is just to make it cancel. So what do we get? We get something which is not very bad. We get 16 y square plus 9x square equals to 16 into 9. Hmm. So, yeah, no, this is not the, because see now what you can, like, if you're in an exam, then maybe what you can just do is you write, okay, 16 into 9 is what, 144. So 144 minus this, and you take the square root of this by 3. This is equal to x. Now when you put it here, yeah, when you put it here, then you will get a cubic 3 degree. What will be the degree in y? Oh, you will get a 4-degree equation in y, 4-degree polynomial, which you can try to solve, or you can guess some solutions by various techniques that we know. But that's certainly not what we want to do. This guy has made this question, so it would certainly be having some geometry. So don't want to write all these equations. Maybe we'll use one equation in the end if we need to, but sorry, so we've spent a long time on this question now. This is,
Sir, EC will be 3/4 of x plus y, right?
why 3/4 of x plus y? No, AC should be bigger than x plus y. AC is the diagonal, right? It's bigger than.
Sir, not AC, EC.
Why is EC 3/4 of x plus y?
Sir, we've been given the lengths of the right angle triangle, right? AEF.
Hmm, I missed it. It was, yeah. So then you are saying, so what are you saying? Like 4 by x equal to, or maybe, yeah, better to say 4 by x plus, So we use the similarity but incompletely, and so hmm, this is nice. Yeah, can't miss these things. So what do we get? I'm getting, no, I'm getting y is equal to 3x, which is fine. That's probably what you're also saying. So this is okay. Yeah, so y equals to 3x. Sorry. So this is 3x. Yeah, now we can, now it is easy, right? Am I correct? Yes. Now we know everything. It was everything was here. We missed. Is it okay?
So now we can apply Pythagoras theorem and find x.
No, I already, yes, I already applied that, right? Yes,
Yes.
that's right. Yeah. Right. Because that was just similarity, these two. I did not, so first mistake is that I did not write the full similarity where I should have maybe. And yeah, just bad. Okay. So let's try more questions. And no one also noticed it. That's not good either. Yes. So more questions. Aparna, you have tried more questions?
Sir, I have not tried anything else, but uh, I mean, I couldn't try the ones you gave. I mean, I forgot actually. You had given the other four problems in another book, so maybe we
Yes.
can try.
Yeah. In the other one, yes. So let's actually try one of them and see if we can do it. Let's see how difficult it is. Right? And so I have said why that technique and all is there, but let's actually try some problems. We have always constructed parallelograms for all sorts of purposes. And I also gave a lot of questions in the passing, right? When I'm talking, I give a lot of things that you have to complete or have to show. If you've tried them, then you should ask. You should try them and ask me, maybe. I should say like that. Let me not try the very first problem. Maybe it's too easy. Not undermining it, but let us try. Let's also not try second one. Let's try the third one, or let's try the fourth one. Okay. Yeah. I was trying a little challenging one. I don't want to just try very easy questions. So please try the problems. Okay. Find the time and try the problem. See, this is mathematics, and from the perspective of you like it, or just, I mean, if you are competing, just imagine others are practicing. I mean, either ways, we used to always, I mean, we still, whatever we do it all the time, practice it, and whenever we get the, yeah, means you can't stay away from it for very long, right? You have to get better at it. There is a, and getting better at it is important, and it is also what will make you more interested. Like if you're committed to it, means you're at least to some extent you're interested in it, right? And then how do you get more interested in it? By giving it more time, right? Then it will reveal more of its good, and then you, in that way you also, right, so then you build a deeper connection, but that will come by giving more time. Okay, either in any way, either via discipline or via interest. You people do have interest. I mean, that's why you're doing this. This is not schoolwork. It's not a necessity, right? So you have to try to give more time. Like I somehow used to give a lot of time in, yeah, when I used to do Olympiad. Obviously now I give time to the maths I do and not to this, but obviously it's because I've already done a lot of it already. So you have to, yeah, you have to take it wisely and see what it is. So let ABC be a triangle and this be a midpoint of BC, and then we construct squares, and then we want to show that this PX is 2 times, oh, PX is 2 times the median. I like this question. This is an arbitrary triangle. This will not work. Take a smaller triangle. Yeah, you just draw a smaller triangle. So that length and between the two squares, the two vertices, that is equal to the median, or not equal, it's 2 times median. Let's see, this should be challenging.
Sir, I think I solved the question.
Oh, this one? Okay, how do you do it?
Sir, so I took the length of AC as X,
Okay.
AB as Y, and AM as Z.
Okay.
Now, if you take the angle, I mean, the angle PAB is 90.
Mm-hmm.
Uh,
Okay.
Sir, won't PAC be, so PAC won't be collinear?
PAC, no, they are not. No, why should they be collinear? Because BAC is not 90, right? So have you done it for a right angle triangle then? Something like this.
Yes, sir, I think.
Yeah, for a right angle triangle. So then, okay, so just, but please say your reasoning. Just from this picture, X, Y, and Z. Then,
Sir, so if they're collinear, then uh, what do you say, like, a PAC will also be 90.
B, A, C. No, B, A, C. I don't understand.
And no, sir, you wrote C twice. Like,
Okay, and I wrote right. So PAX is collinear, is what you're saying? No.
no, sir, I meant that PAB will be 90, right? So VAC, if they're collinear, then that will also be 90.
No. PAB is 90. No, which one is 90? Uh, PAX.
Sir, in the second diagram, I want to say that PAC is 90. PAC.
PAC is 90. PAC is not 9.
B, sir.
B or D?
Yeah, BAC.
BAC. Yes, yes, yeah.
Yeah.
That's so it's a right triangle. Yes, yes, that's right. Yeah.
Sir, in that case, then we can say that the median where it will divide the like each BM will be Z, right? BM and MC.
BM will be right. That's correct. And then the problem becomes trivial. Right. Yeah. Because we know that in a right triangle, the median is just right, because you know all that. That is right triangle, then these three are same. Right? Why? Because this simply, when you draw a circle, then this becomes a diameter. Right? So then that becomes a center. Yes, and then it is absolutely trivial. I suppose, um, right? Because it's just clear that this is 2z. You can see it any way you want. This is 2z, this is 2z, and that is 2z. Yeah. But what is remarkable is it's still true when it's not 90 degrees. This problem can be done. Again, you can again put some cos of that, and so just when this was 90, you calculated. Otherwise, you put theta, and then this 180 minus theta, because again the sum is 180, because other two sum is 180, and then you can do it, right? You can use your good old Apollonius also, right? This AM, you know what it is. If you keep these as your variables. Um, okay, so this is some completely bad kind of notation. Did I take it from him? No, his was okay. It's my own bad notation. So a by 2, a by 2. I mean, the point is that these two triangles are not very different. Trigonometrically, they are not very different, right? So use the cosine rule to find px. Well, why am I saying I just do it now, right? I know this is a trying parallelograms, but yeah. What is px by the cosine rule? Px square is equal to c b. So px square is what? It's equal to c square plus b square minus 2bc plus 2 cos theta, right? And this is cosine rule. Now again, what does Apollonius theorem tell you about am square? Aparna, can you help? I forget. I will never. I'll not. It's difficult for me to remember these things.
Sir, it will be B square plus C square minus A
B,
square by 2.
b square plus c square
C
minus
square,
a
C
square
square.
by 2. Yes, right. The by 2 comes because of, yeah, minus a square by 2. And then you can apply again the cosine rule, because you don't want the a, right? So the a you can again rewrite, and you'll get the same thing back. Okay, just do it. Just rewrite the a, and you see what is a square? Again, c square plus b square minus 2bc. Just check it. There will be some plus minus and whatnot here and there, but you can check it. Yeah, like maybe is, but you understand, right? It will come out to be the same, or two times that it's what it is. Yeah, that's what it is, right? Yeah, it's done. So you see this problem again. You see, this is not. I've not done it. Have I done anything? No, I've just used trigonometry. Like absolutely no creativity in this problem I have used. Just done trigonometry. Okay, that creativity is encoded in those nice trigonometric formulas, is in those nice cosine sine rule, in this nice cos 180. That language, that nice things is put in the language. Okay, so that then it becomes an automatic machine. Okay, So, but how do we do this? You understand, right? Still the problem is sort of not solved. We want to draw. Does trigonometry suggest anything in construction here? Drawing parallelograms. Like this kind of construction is used, right, even to prove the Pythagoras theorem, right? If you're teaching, I just discussing or teaching Pythagoras theorem with someone younger, or you draw squares and try to prove it, right? Area of the two squares added to the other one. But we've seen how useful trigonometry is. What construction should we make? I do not know. Squares. Like I know one way to bring in 2a in the picture. So we don't want to deal with this theta and so on, these angles. Otherwise, because this problem is not even computational. If you use trigonometry, it's not even much computational, it just falls easily because it's an appetizer. But one way to bring in 2a, because I want to bring in 2a, I want to see 2a as a length and not as a plus a, right? Then you know what I'm doing, just completing the parallelogram. This way I get the 2a. And this is also that. Oh, you know what I should show? AT is 2a. I want to show px is 2a. This is C. This is B. I should show that the triangles are congruent, right? That is how it should come. Logically, that's not the point. But what's the problem trying to tell you? That you should show this. Logically, what is true is not always helpful there, right? A, C, T, X, A, B. Just show that the triangles are congruent, please. Oh, or is it? Yeah, it's trivial enough. This is theta. This is 180 minus theta. Yeah, and it is true by SAS. Done. Is this clear?
Yes.
Yes.
Okay, Nagesh.
Yes.
Yeah, I've just followed the chase. I've just followed just the clue. That's all. Not much. It's nothing. Right. So to prove something, you see, you have to prove there are a lot of statements. There are a lot of things that are true. Right. A lot of truths are there. There's some very trivial truths, harder, even harder. So there is this layer of truths where it gets harder than the other. But among those sequence of truths, there are certain truths which are easily provable. Right. So when you're trying to prove a truth which is suppose 99-degree hard, but maybe it's not easy to prove. Maybe the you just go a little higher, and so that's what we are doing. We are seeing this as a part of something bigger. I mean, apparently showing that those two are congruent is a bigger fact, right? But it's easier to prove. It is more easy amenable to logical reasoning, because in maths we have the constraint, we have to do everything conclude by logical. That's kind of a constraint actually, right? Yeah. How does it help in life? I don't know. Right. But with that constraint, we have to figure out what's the closest truth which is easily provable. And that will be hinted by the question. Obviously, maybe you don't think like that. Maybe it's not very useful at this stage. I don't know, but it's easy. So in fact, we see that we don't really need we really need a square. I mean, you can. I know you will not think about it because again, it's a little scope out of the scope. But if you want to, you can think. Basically, I'm saying that if you have any alpha and beta which add up to 180 degrees, then this is true, right? If alpha plus beta is 180 degrees, right, and you make this sort of circular thing, the square is not really needed, right? All these facts will still remain. We didn't really use those other things. Just alpha plus beta should be 180 so that these two are also adding up to 180. Okay. And that alpha and beta is 180 probably can be encoded in a more tricky way that this is beta and there is some cyclic quadrilateral and this is alpha and then there's something which forces this two to become equal, some similarity. In a more complicated way, it could be encoded and then you have to get it. Yeah. Anyways, so you see the problems are nice. At least I would feel, right? So it's nice. In fact, I would try a few of them later, the harder ones also. You should also try, right? I'm not asking you to do the rest, but at least do till problem number 5. Okay. That's it for today. Take care. Goodbye. We'll meet on Sunday, 9 p.m. Please find the time to try. You have to do it. Okay. And we will try to get as much done. Now we'll do at least 5 questions next class. Okay. We'll do 5 questions at least. All right. All right. See you on Sunday. Bye.
Thank you.
Hi, sir.